Okay. Thanks for that, Curtis. Again, you're my savior when we get to recording because I always forget. I don't know why. I just do. So again, the run and the rise are equal always in a 45-degree right angle triangle. The travel is always 1.414 times longer than the rise or the run. Now, when we solve offsets, we're going to use triangles to find our lengths. And almost always our lengths are going to be in center to center measurements. So that's what we're going to have. As you see that last assignment, we started doing a little bit of fitting allowance, and I just put some numbers in there just to make sure people are paying attention. Okay, so always pay attention to CC or E to E, which is end to end. So always pay attention to those as we move through, because that could mean a right question or a wrong question. You know, you can do everything correct, but if you don't get the very bottom end. Any questions before I keep moving on? Awesome. Let's see the pile of papers I have here from our classes. It's crazy. This is my notes, I guess. Getting out of hand. So, which brings us to, that's one of the sheets I asked if you could possibly print it. It's advantageous to have this printed. And I'm going to try, well, I'm not going to try. I'm going to solve for this dimension. So this is a piece of pipe right here. This right here is a piece of pipe. So this is a piece of pipe that you have to install. It's 900 mils from the corner, 125 from this wall, and 150 from this wall. Now, to remember how to get a perfect right angle, or if you're working with a perfect right angle, to remember that rule, what is that called again? Anybody know? Shout it out, you know?
3-4-5 rule.
That's right. It's the 3-4-5 rule. I'm going to assume right now, because this is a pretty good corner, that is a perfect right angle for me. So if you're out in the field, I would suggest you figure out if you're working with a perfect right angle before you do some of these measurements, because if you're not, things aren't going to be straight. Okay, so the first thing I'm going to do with this picture is I'm going to draw a very big right angle triangle. And I had a ruler here. There we go. So this is where I get my ruler out. So if I had a measurement from the corner, right here from the corner, I'm going to draw a straight line to the center line of the pipe, and I'm going to make my right angle triangle. Now, everything I'm going to do right now is 45-degree fitting. So everything is about the 45s. Everybody see that big right angle triangle I just drew there? I'm going to draw another one right beside it, so I have two of them. Look at that, beautiful. So colorful. So I have 1, 2 right angle triangles. Now this rise or offset right here, or the rise right here, this one that says 900 mils. Now we know that if this is 900, this has to be 900. And if this is 900, then this has to be 900. So I can determine through those measurements right there that from wall to wall, so from this point to this point, my wall to wall measurement is 1800. Can everybody see that there? Is there any questions about that? as we move forward. So now I have my wall-to-wall measurement, and as you can see, I need to remove this piece, and I need to remove this piece length to then get my dimension in the middle. So look at this little triangle right here. You see the green triangle? That's really tough to see. I kind of should have used a different color. But there's my triangle. My right angle triangle is sitting right there. And if I had a run of 125, I can then determine what the travel is by simply multiplying by 1.414. So that means that this measurement right here is 176.75. Wow, that's small writing. Here, let me zoom in. Everybody see that? All right. So we got that piece. Now I just have to get this other piece over here. So I'm going to use another color. I don't know if this is even going to show up. No, that's really bad. I have to use green again. There's my other right angle triangle right there. And I have on this, the rise of 150. So I will figure out the travel by taking 150, timesing it by 1.414. So this is 212.1. Now, if I take these two things and minus it off at 1800, plus 176. So that dimension right here is 1411.15. How's everybody doing? Good? We got that? Yeah?
That's pretty
easy,
cool.
huh? It's pretty easy. So we're just using basic right angle triangles to solve for these dimensions. And that's what we're going to do for the most part. Okay? So this, let me just go back to this screen share. I'm going to make a note at the top.
You're no longer sharing your screen with us.
Oh, I didn't hit the button. There you go. So when I have a measurement from the corner, if I'm given the measurement from the corner, this is the process. This is the process from the measurement from the corner. Oops. And I just want to get another sheet here. Oops. I grabbed something, but I don't know if it's printing. Let me just, hang on a second. I gotta turn on my printer. darn thing. Okay, good. Any questions? Any questions? Any questions? Any questions? Okay, I have another example that I want to do this with you, okay? Another example from a measurement from the corner, and trying to show up here. A second. My printer is slow. Should have had this printed beforehand. Sorry about that. And if you've had common first year math, you would have already done this. You ready? We're going to start another one. Here we go. Can you see that screen with my hand? Is everybody okay with that? Can you see that?
Yep.
Yeah, okay. I just don't have the thing around my screen like I normally do. Okay, so here we are. Do we have a measurement from the corner on this one? Is there a measurement from the corner?
Kinda.
Yeah.
Yeah, there is. We have a measurement from the corner. So if you have a measurement from the corner, draw your triangle starting from the corner to the center line of the pipe. And we will make a two large triangles here from wall to wall. And as you can see there, let's find our wall-to-wall measurement. Does anybody figure that out? Can you just shout it out to me?
2,200.
That is correct, because this line is 1,100, that line is 1,100, that has to be 1,100. So wall-to-wall is equal to 2,200. Very good. Now, we have these two other measurements we have to take off our pipe. So I will draw a right angle triangle right there and one right here. And we will simply go 300 times 1.414, magic number.
424.20.
424.2. And we have one of them, we have two of them because they're both the same, yes? So times it by 2, that's 848.4. I go 2,200 minus 848.4.
1,351.60.
Beautiful. Somebody just join our room. Oh, there's the one person we missed today. Mohammed. Hello, Mohammed. Mohammed, are you there? Mohammed. Mohammed.
1 second.
Hey, how you doing?
Oh shit, my mic was unmuted. My bad.
That's okay. How are you?
Sorry, I slept through my alarm. I'm good.
Yeah.
Yeah.
You know, my 18-year-old kid does that too. I mean, I could be upstairs and I could hear his alarm going off downstairs where he sleeps and he doesn't wake up, but I could hear it. Doesn't wake up? It's a problem.
Yeah, I have that problem.
Did you stay up too late last night, Mohammed?
A little bit, yeah.
All right. Well, welcome to class.
Thank you.
I want to ask you if there's anything that I could help you with. How's things going? Why don't you unmute your camera for a second? I know your hair might be messy, but that's okay. So is mine.
Give me a good one.
Hey,
Yeah.
sorry, what?
There you go.
There you go. Yeah. See, just put on a hat. That's what I do.
That's all I have to do, man.
Yeah. Okay, so things are going okay though. I mean,
Yeah,
of course.
Yeah, things are going pretty good. Things are going pretty good.
Good.
Can't
All right.
complain.
So where we are is we just finished one offset here. Let me just show you what we just did. Whoa, that's not going to be good. I'm going to share my screen again here. And we just did this.
Ooh, looks like fun.
Yeah. So this is when you have a measurement from the corner. So when you have a measurement from the corner, you draw a big right angle triangle all the way across. You get your wall-to-wall measurement. And then you draw these little right angle triangles to get this measurement. So if we know that this is 150, 150 times 1.414 is equal to 212.1. So then we remove that and this one from our wall-to-wall measurement to get our dimension. Okay. So, and the next thing we did is we did another example here. As you can see, that's how to solve for that one. So this is the process of a measurement from the corner. So we're going to expand on this and we're going to do some more. But first, let's take a 10-minute break, come back and go get some coffee or some cereal and whatever it is that you need to get. And we'll come back and we'll continue on with this. So here is the next thing we're going to work on. I'll give you a minute to draw it out if you don't have it printed. Okay, well, clearly on this particular picture, we do not have a measurement from the corner. I got this 36-inch diameter something in the way. It could be a pipe, could be a hot water tank, could be a pillar. I really don't care what that object is. It's just we're given these measurements and then we have to determine that measurement or the dimension of our travel for that piece of pipe that's there. So this is the process for solving this particular offset. So anytime you do not have a measurement from the corner, okay, we don't have a measurement from the corner on this one. Anytime you do not, what we do is we start from the center of our object. So if you can see my little red dot right in the middle of that object, and that's where I'm going to start. And I'm going to draw a line parallel to the outside wall right here straight off of my thing, but it has to be parallel to the wall. So I'm gonna draw a line straight down parallel to the wall, to the center line of the pipe. And then I'm going to draw another line parallel to this upper wall, to the center line of my pipe. And I know it may not look like it, but quite frankly, what I just did there is I drew two 45-degree right angle triangles. So I could, maybe that's not as dark as it needs to be. There we go. Okay, so you can see now that I have this two right angle triangles. Now, if this line right here is 16 inches, this line right here is 16 inches, that means this is 16 inches and this is 16 inches. So I can assume.
Why would it be 16, Doug?
Don't you have
Because
to add the
you see-
radius?
Oh, gosh,
Should
it's
be
not
30.
16. You're right, it's not 16. I did that wrong. We have to take half of this, so this radius is 18. So this line is actually 34 inches. Wow, I messed that up, didn't I? Thank you for that, and I'm glad you're speaking out because that's important. Let's see here. Hey, let's start over. I'm going to draw my lines again from the center of my circle because I made a mistake. Beauty. Okay, there's my two triangles. And this line is half of 36 right here. So that's 18 plus 16. So this run or rise right here, this rise is 34 inches. So that makes this line 34 inches and this line 34 inches, making the entire piece from there to there 68 inches. Does everybody see how I got that?
Yep.
Are there any questions on how I got that?
No.
Anybody? No?
I don't know how you got the 34 inches, Doug.
Okay. So right here, you see I have, this is 36-inch diameter, right? See that? Can you see that, Sean?
Yes, I can.
Okay, so half of 36 is a radius, so half of 36 is 18. This line right here is 18 inches. And then I added 16 inches to that to get me all the way to there. So 18 plus 16.
Okay.
Okay, now it's important for me to say this. Does everybody see the NTS on my paper?
Yep.
We know what that means?
Yep.
Not to scale. None of this is to scale. This is all an optical delusion almost, if you will. So nothing is to scale. We're using the measurements that we have, okay? Sean, do you see where I got the 34 from?
Yeah.
All right. The next step is I need to solve for that piece right there. I need to know the length of that particular piece right there. So that piece right there is what I'm going to solve for next. So I'm going to treat this line that I drew there as a travel. And I'm going to draw a right angle triangle right there. There's a right angle triangle, and this piece is the travel. So to determine the travel measurement right here, I first have to get the measurement from this orange line to the wall. Okay, so from there to the wall, I have to get that measurement. I don't know if that my pencil's showing up very well. It's not. I might have to use a pen. So I need that measurement right there. And that measurement is calculated by going 18, that's 18 plus 15. So this line's total is 33. Did everybody see where I got the 33 from?
Yep.
Okay, so that's 18 plus 15 is 33. And if I look way over here, I can see I have 12 inches. So if I take 33 and minus 12, that's 21.
How did you find the 18 inches?
Okay, that's
Radius.
half of the 36-inch circle right here. You see it?
Yeah.
That's 18. That line is 18 plus 15. So from this line to the wall is 33.
Gotcha.
Okay, and then I'll minus off the 12-inch measurement that we have over here. So then 33 minus 12 means this line right here is 21 inches. So I can get a travel from that if I go 21 times 1.414. And that's going to be 29.694. So this measurement right here, this travel is 29.694. And we'll repeat the process for the bottom corner. Now, again, this is the travel that we need to solve. Right here is the travel. I will draw a right angle triangle. There's my little right angle triangle. The next step is to get the measurement from the line to the wall. This measurement. That's 18 plus 11. This line is 29 inches. And then if I minus off 14 down at the bottom from the 29, that makes this line 15. And now I can go 15 times 1.414. $21.21. This line right there is 21.21. And I simply have to add them all together. So the 29.694 plus 68 plus 21.21.
118.904.
there's my dimension. Wow, what a dog's breakfast that is. I don't even know what that means, but. I'll give you a minute here to write it down, write it out before I move on. We're good? Should I move on to the next one? Everybody?
Yeah, I'm good.
All right. Okay, this next example is crooked. This is another one without the measurement from the corner. Okay, this is another one without the measurement from the corner. So the first thing I do is I start from the center of my circle. And then I will draw a line parallel to the outside wall to the center line of the pipe. And again, parallel to the outside wall to the center of the pipe. Now I have two 45-degree right angle triangles. So if this diameter is 650, so if diameter is equal to 650, then the radius has to be 325. So this is 325 plus 500. So that's 825 and 825. For this measurement now is 1650. Does everybody see where I got the 1650 from? I will take your silence as you got where I got the 1650 from. The next step is to solve for this piece right here. And this is a travel that I'm going to solve for. And I will draw a right angle triangle. There's my little right angle triangle. I'm going to get the measurement from this line to the wall. I want that measurement. I take half of the 650, 325 plus 280. So that's 325 plus 280 is equal to 605. So this line right here is 605. And if I minus off the 300 over here off of the 605, that means this line right here is 305. And I could then determine what the travel is by going 305 times 1.414. And that's 431.27. So this is 431.27. Now, the next step is to solve for this piece right here. And this is another travel that I'm going to solve for. And I'm going to draw my right angle triangle in here. So I have my right angle triangle right there. And now I get my measurement from this line to the wall is 325 plus 200. So that's 525. And if I minus 300 off of the 525, means that this line right here is equal to 225. And I can solve for the travel now by going 225 times 1.414. It's equal to 318.15. So this is 318.15. And now I simply add all of these together. For a total of 2399.42 is our dimension A. How's everybody doing? Did we kill anybody yet? I don't think so. It's not that bad.
No, we're still alive, man.
Yeah, that's good. That is really good. Okay. I'll give it a minute here. I'll leave it up there for a minute. It's a lot of numbers on there. Should we do one more example of this one? I want to gauge from you guys. One more example? Yes, no, maybe so.
Yeah, might as well. It doesn't hurt.
Yeah, I don't think it'll hurt us.
Doug, can you put the original one up that you had first? I'm just going to screenshot it, if you don't mind.
Sure, you bet. This one here? Well, let me just zoom out. That one?
Yeah.
Okay, sure thing.
Yes. That's great. Thank you.
You're welcome.
I'm sorry, I don't have a lot of space here in my place. My laptop takes up half my desk.
Well, I tell you, man, you know what? I have, my desk is completely full too, but I have a secondary screen, which is very helpful, I must say. Having a second screen.
Okay.
Well, a secondary screen and a printer, I must say, helped me. And if it helps me, it'll probably help you. So moving forward, if you guys are going to do more online stuff, you might want to consider getting that. Okay.
Good.
Okay, let's do one more example of this. And I'll just do this one right here. Oop, let me just get it centered and then I'll zoom in.
Can you give me a second to draw this out before you go through the calculation?
Sure thing, Sylvie. Go ahead.
Thanks. Sorry, it'll just be a sec.
Don't be sorry. This is okay. I have no problem with this. The way it is. I want everybody to be okay. So if you want to take a minute and draw that out, by all means.
Is this in our ILM?
No.
Oh, okay.
These are examples that I'm doing just with you guys.
Okay.
And there might be some of the same ones on the assignment, which is good.
Okay, I'm set.
No, awesome. So a little bit of lull in the program. Mohammed, did you have a quick nap in there? I hope. Nice and fresh, no? Just kidding. You don't have to.
Hey, Doug, could we have maybe 5 minutes to try this ourselves before going through it with you?
I will give you another one. How's that?
Yeah, that
Let
works.
me do this example with you, and then I'll show another one that you can do.
Yep, that works.
All right. So let's do this one, and then I'll put up another example for you to do. Okay, so again, we do not have a measurement from the corner. So anytime we don't have a measurement from the corner, we're going to start from the center of that object. And I'm going to draw a line parallel to the outside wall, straight to the center line of my pipe. And I'll do that for the other side, parallel to the wall, to the center line of my pipe. And I will draw two 45-degree right angle triangles. And I will then determine the rise of that triangle. So the diameter is 210, so the radius has to be 105. So this line right there is 105, and this line right here is 150. So that is 255. So this measurement has to be 4, 5, 10. $510. The next step is, this is the travel that I want to solve for next, the rest of this pipe. This is the travel that I want to solve for. And I will draw a right angle triangle right here. And there's my right angle triangle. I'm going to then get the measurement from the red line to the wall. This measurement. This is 105 plus 90. This line is 195. And if I minus off the 100 off of the 195, that means this line right here has to be 95. So I can solve for this travel now by taking 95 multiplied by 1.414.
Sorry, can you, I was scribbling. Can you just go over that one more time?
Sure. So I first have to get the measurement from the red line to the wall. Half of 210 is 105 plus 90, so this line is 195. And if I minus off the 100 over here, means this line is 95. So I could solve now for this travel if I take 95 times it by 1.414. And that would equal 134.33. So this line, 134.33. Now, my next step is I need to solve for this piece right here. This is a travel. I'm going to draw my right angle triangle in there. And now I'll take the measurement from the red line to the wall as 105 plus 90. This is also 195. And then I minus 80 down here at the bottom. So that tells me that this line, this measurement right here is 115. This has to be 115. And now I can calculate the travel by saying 115 multiplied by 1.414. 162.61. So this is 162.61. Now I add all those together. For my dimension A is 806.94.
In that situation, couldn't you just get the coordinate measurement if you wanted to?
No, because what happens is down here I have 80 and then I have 100. So it's not even. And sometimes these two measurements, 90 and 90, aren't the same. Sometimes these two measurements will be different. And then we get really unfair lines.
Okay.
Sometimes it can work, but other times it doesn't.
I just tried it this way and it worked this way.
Yeah, well, I don't recommend that way, okay? Oh, somebody just left or somebody just entered. One or the other. Okay. Now I'll give you an example to do on your own. So take the next, I don't know, 10 minutes and solve for this one. Solve for pipe A. Do we have anybody who's finished it yet?
Yeah, I'm done.
Yeah,
I'm
finish.
on that.
Done. Yeah.
Yeah.
Yeah, I'm gonna share this. I'll be right back.
Okay, I'm gonna do this stupid shit real quick.
All right, so that's not too bad, is it? Okay. I get a thumbs up. Do I get anything? 135, yes? All right, all right.
Straightforward there, Doug.
It's not too bad. As long as you just start, like I love to write stuff in, okay, on my pages. I write in the measurements I know, and I write in the stuff I know. And after I do that, I could usually figure it out, even if I don't know what I'm doing. At least I'm on the right track. So you ever get stuck, just write down what you know. And then you can move on from there. Okay, so let me stop sharing here for a second. Does anybody need that on there still? Okay, stop sharing that for a second.
Oh, I think Sylvia needed it for a second.
Oh, you still need it? Okay, that's fine. But it's still a little too early to start day drinking, so I'm gonna wait a little while longer.
It is absolutely not. Bailey's in your coffee is perfectly acceptable.
You know, that is true, but I don't want to stop there.
Have some beer and orange juice.
Oh yeah, lovely.
You just coast through the whole day, no problem.
Let's try to keep that even buzz all day long.
That's it.
Well, you know what? We're down to one car. My son took my other car up north. He just moved back to Drayton Valley. So my wife and I are sharing a car, and I tell you, it is hard. I don't like it. Not at all.
Okay, I'm good. Thanks for that.
You got it? All right.
Yeah.
Yeah, sharing vehicles is difficult at best. That's just my own personal struggle. You don't need to know that. All right. Now, assignment number 6.5. 6.5 has now been released for you to do. And it is all about offsets around corners. Okay? And there's only 10 questions. And I think we've already did 3 of them. So assignment 6.5 is going to be super easy. Okay? So what I'm going to do is I'm going to let you guys work on assignment 6.5, the test. You can get the PDF document first if you want to first try to find your answers before you enter them into D2L on the test portion. I'm going to give you 1 hour to work on it, okay, on assignment 6.5. So you have 1 hour to work on it, and I'm going to come back in and check on you and see how we're progressing, okay? Is everybody clear? 1 hour, start assignment 6.5. I'm not telling you to finish. I want you to start it. So you'll have 1 hour to do some of these offsets and offsets around corners, solve for those. And in 1 hour at 10:45, I'm going to check in again with you. Okay? So now it's time for you to do the work, not me doing the work. Okay? So you can mute your camera, you can mute your microphone, but stay online. Okay? Stay online, and then I'll come back in and check on you. And if you have any questions, please type it in the chat or whatever. Okay? I'm here for you for the next hour as you're working on this assignment. Okay? Cheers.
All right, Herc, move.
So that way you get to see yourself in the recording, and then it's just not me talking, right? So Alec, Josh, Dylan, Jake is in here twice, but there you go. I guess they're not available. The next thing that we're going to cover is trigonometry. Okay, so that should bring you back to your junior high school days, right? Trigonometry. So it's not that hard. We'll go through it step by step, and terminology for going over trig is super important. I'm going to give you all the tools and the skills you need to become an expert at it. Okay. Whatever angle, whatever triangle, we should be able to figure it out, and we'll do that. Now, I accomplished what I wanted to do today. That is to talk about offsets around corners, and that is to get you to start your assignment. Now, I'm going to show you something here. Let me see. I got to pull it up. I'm going to have to do a big screen so I can see this because I'm blind as a bat. Where the heck is it? Well, I'm not going to find it there. I got to find it in another place. I know where it is for sure, in here. Sorry this is taking so long here. Sorry. Should have had this pulled up when I wasn't doing anything, clearly. So I'm going to share this screen. Here we go. Can everybody see that beautiful parallel offset project? Okay, so half the class will start this on Monday, and then half the class will start this on Friday. So I am going to come in on the Monday class, and I'm only going to have 12 students, and we're going to solve for all of these measurements on this particular pipe using our triangles, and we'll figure it out. There is one step that we're missing, and I can talk to you about that on that day. And it's just one little piece about a 22.5-degree right angle triangle. And we'll figure that out. We'll figure that out together. So this is the kind of stuff that is now applicable to us as we move forward into offsets. Okay, so offsets tend to start to get a little more difficult, a little more involved. Let's see if I got something here. And it's going to get to the point where it's going to look like this. Can you see that equal spread offset on your sheet? Okay, we're going to be doing stuff like this. So I'm going to get you this booklet here that has all of these in here. I'm going to print them all off for you. And we are going to do all of these together the following week. So it kind of gives you an idea of what we're getting into. And I feel it's important that we do this, and that's why we're going to do them one at a time. We're going to do them together, and then you're going to do the assignment, and you're all going to get 100%. And that's, you know, how can you do better than that? You can't. So again, I've covered everything I wanted to cover today. So the rest of the class, you guys can work on whatever you want. I know you have a couple classes coming up with both Rob and Dennis this afternoon. So whatever you need to get done for them, please get done. This is your opportunity to do some work. You know, make yourself some KD or whatever it is, and enjoy the rest of your weekend, because this is Friday, the end of week 3. We're done, week 3. Can you believe it? I didn't think we'd survive, but again, here we are. Us humans are pretty resilient, and we could overcome lots. And this little bit of math is easy peasy, lemon squeezy. Last week I had some issues, I think, with the tutoring class. I don't know if the link worked very well. I heard a couple people couldn't get in. So I'll resend that link, and look for that link on the front page of your D2L for math. I will post a link there for math tutoring for Tuesday. Now, before we leave, does anybody have any questions of me? Why you have me?
Yeah, Doug, I have a question. For Monday, are you guys gonna send out the groups that we're splitting up in, or is that just gonna be done at the school?
Excellent question. Most likely we're going to do it at the school, but the groups are going to be purely alphabetical. The top half, the top 12 go to one shop, and the bottom 12 go to another shop. And you're going to have Dennis, or you're going to have Rob. You're going to see me on Monday morning. I don't even know what group yet, and that's about it.
All right.
Okay, so remember the things you need to bring, right? Your lunch, your PPE, some masks, a sense of humor, your patience. You know, don't, Steve, leave the cat at home. Cat's not allowed to come to school. Just kidding. Just kidding.
So he is
Hey,
allowed.
Doug,
Yeah,
is there any modules that go with any of the shop classes that we need to bring?
that's a great question, and I will let you ask that of Dennis and Rob today when you have them, okay? Please ask them as many questions as you think you have about shop, about what you need to bring. I'm going to say that you need to bring calculator, pencils, maybe a straight edge, and a little bit of paper so you can take your own notes. So one binder at the very least. I'm not going to request that you bring your laptops, but if you have your laptop there and you have some downtime, lunchtime to do whatever, let's just say that you can do that. So make sure you're bringing your lunch and enough for everybody. Or no, I'm only kidding. I don't want to eat your lunch. Okay, so And I'm bringing my golf clubs because at lunchtime, I'm going over to Confederation to hit golf balls. But that's just me. I don't know about you. $6 parking, right? $6, pretty cheap. I'm happy about that. That's like a bus fare to and from home. $6 to park on campus all day. So do that. You will be entering in the main doors of the Aldred Center. Somebody's going to meet you outside. Make sure you have that SATE Alert app on your mobile device because you have to do a daily check-in. All right? You have to do a daily check-in every day. You show up to SATE. You have to do the daily check-in. And you can't enter the building until you've done it. And you know what? We're going to have a tablet there, and we're going to see if you've done it or not. We'll just say, no, Sylvia, access denied. So get the SATE Alert app. And for those of you that still have to finish that online course, that prior to entry into SATE, you have to do that orientation thing with little animations in there. So make sure you finish that if you have not done so already. Any other questions? No? Have a great weekend. Thank you for your patience. Thank you for your time. I appreciate you and you and you and you and you. Okay? Have a great day.
Doug, can you walk me through one of the
Have a good one,
problems right
Doug.
quick?
Yes, I can, sir.
Number 3.
Okay.
You want me to share screen or no?
Let's have, I think I have number 3 here. Let me just.
I tried to do the same equations that I did from 6 up, and I tried to do that from 3, and it's different because there's a line going from the top of the circle, and
So
the other
we
ones
have-
aren't showing.
So Sean, we have a measurement from the corner. Yes?
From the corner, yeah, there's 300 in the corners.
Yeah,
Is that what you
so-
mean? Yeah.
Well, no, from the corner of the walls, where the walls meet, we have a measurement. You see
Okay, yeah, this is 200 up there.
So 200 plus 400 plus 500.
Okay, that's 1100.
Right, so we can get a wall-to-wall measurement of 2200.
100. Okay, times 2 is 2200.
That's wall-to-wall. Now
Okay.
we're going to remove the travel on both ends. So we have a 300 rise
Okay.
and a 300 run. So we're going to go 300 times 1.414.
300. 300 times 1.414 equals 424.2.
Right.
Yeah.
I think I did this one.
Okay.
Yes. And now we have to remove both sides of that 424.2 from the 2200.
Okay. So 424.2 times 2
Yep.
equals 848.4.
Yeah.
Take away that from 2200. Oops, that's not wrong. 2200. Wait, 848.4. 1351.6.
Perfect.
That's all there is to this.
That's it.
Oh my God, that's pretty easy. I'm sorry, I'm paying attention, but sometimes I had to go through them quite a few times, right?
And that's okay. That's okay if you go through them a few times.
Yeah.
Hey, Doug.
Yes, Curtis.
I hit the wrong button.
What are we talking about? Like,
The answer.
did you launch some missiles or something? I mean, what's that?
Yeah.
What can I help you with, Curtis? Sorry.
Yeah, for question 10.
For question 10,
I got
You-
the
you
right answer,
entered-
but I hit the wrong button.
you hit the wrong button, so you already submitted your answers?
Yeah.
I put 2651.
Yeah, that's what I got, but I hit D.
Okay, let me have a look here.
Oh, I see what you mean, Curtis.
Oh, so you only got 9 out of 10. Let me just see here. What button were you supposed to press, Curtis?
B.
You were supposed to press B. Let me just see here.
Hoping it's the right one.
Well, yeah, B is the right one. Okay, so you know what the answer is, right?
Yeah.
Okay. Check your grade.
Thank you, Doug.
Hey, Doug.
Yes, sir.
I don't know what I did wrong, but I know that I'm getting all these, like I know how to do all these steps, but in the assignment, I got 4 wrong.
Whoa.
I think what I'm doing is like I'm using my down cursor to move down the screen, and I don't think you can do that, and I think it was switching my answers.
Oh, shoot. That's really too bad. So let me have a look here, Justin. Let me just have a look at this.
Thanks, Doug. Take care.
Yeah, take care, Curtis. See you later. So you chose for number 2. Yeah, 92 mils.
Like
Yeah,
I would have never put that. I think what is happening is when I'm pushing down on the cursor.
Yeah, it's coming up. It's coming up wrong. Oh yeah, you got the next one wrong too.
Like, and I
And
know
the
I'm
next
confident.
one.
I know that I know this well enough that I wouldn't be getting like all those in a row wrong. You know what I mean? Like I know.
Well,
how to-
yeah, that's 4 in a row, and then you got all the rest, right?
yeah.
Yeah.
And I think because I was using my down cursor and it was changing my answers and I wasn't realizing it. Do you know what I'm saying?
Yes, I do. You know what? That can happen to anybody, Justin. Check your score there, okay? Check your grade.
Perfect. I do appreciate that because I'm very confident in this.
Good. Well, yeah, well, that's the way it is. It's good. So keep your stick on the ice, eh, Justin?
Well, I appreciate that. Thank you very much.
All right.
You have yourself a good weekend.
Take care. Bye-bye.